Number 3, we need to simplify that. Okay, write it in standard form, a plus bi. So essentially, we've got a lot of things to clean up. Okay, so first thing I see is this right here, square root of negative 75. I want to handle that. Okay, square root of negative 75. We know the square root of negative 1 is I. So you can look at it like that. Okay, I times the square root of 75. Okay, so if I had 15 minus I square root of 75, okay, both of those things are over 5. It's almost like you can distribute your division if you want. Both of those are over 5. But square root of 75, I can break that down. If you want to do it over here to the side, you can, but you probably don't need to do it over to the side. 75 is 25 times 3. 3/4 makes 75 cents. Or 5 times the square root of 3. So this right here is 5 times the square root of 3. So I have 15 over 5 minus I times 5 square root of 3 over 5. Both of those are over 5. Both of those fractions are over 5. You could say 5 goes into 15 3 times, and 5 goes into 5 1 time. So really, we're all cleaned up if you can understand my crossing out. You've got a 3 right here minus. You've got an I, and everything else canceled out except your square root of 3. 3 minus I times the square root of 3. Number 4, find each sum or difference. Well, most of the times you can just look at it and say, well, it's 4 plus negative 5 is negative 1. And negative 5i plus 8i is 3i. That's it. Negative 1 plus 3i. That's the answer. That's the complex number. Okay, sometimes the parentheses get in the way, and I think on subtraction gets really difficult because what people want to do is people want to say 7i minus 3i is 4i, but you just messed up. Okay, if you do it like that, 7i minus 3i is 4i, even though that's true, that's not what this problem says. So be very careful with the parentheses and stuff. In fact, sometimes I think it's a good idea to get rid of the parentheses. In this case, I might distribute that negative. And I'd have negative 10 plus 7i minus 5 minus negative 3i is plus 3i. I think it's a lot more likely you'll get it right if you'll distribute that negative there. Negative 10 minus 5 is negative 15. 7i plus 3i is plus 10i. Now, powers of I is something that comes up all the time, okay? We already talked about I and how I was the square root of negative 1. And if you square that, you get I squared equals 1. But we can extend that and go even further. I cubed, I to the 4th. And so basically, you've got these 4 things that happen. But then they just keep repeating. You've got I, negative 1, negative I, 1. I, negative 1, negative I, 1. I, negative 1, negative I, 1. And so on and so on and so on and so on. Those 4 numbers just keep repeating themselves over and over and over and over again. Okay? So, I mean, they all just kind of build off of each other if you think about it. If I had I times I times I times I times I, you could kind of just like put some together, and I squared right here is negative 1. And here's another I squared. That's another negative 1. And so negative 1 times negative 1 is positive 1. And then you have this other I left over. So that's I. And so that's why I to the 5th is equal to I, or that's one reason why, is because you've got so many of those I squareds inside of it. Okay? Or even better, if you memorize that I to the 4th equals 1. This is really powerful because every time you get a multiple of 4, it's going to equal 1. I to the 8th, I to the 12th, I to the 16th, I to the 20th. Every single time you get a multiple of 4, it equals 1. Okay? So if I said, what's I to the 100th power? That's a multiple of 4. So guess what? It equals 1. Okay? But if I said I to the 101st power, notice what happens with this pattern of numbers. Okay? This pattern of numbers is repetitive. I, -1, negative I, +1. I, -1, negative I, +1. What follows after every time you have a 1? I. So I know that I to the 101st power equals I. Likewise, if I said I to the 102, it's just the next number. It's going to be -1. Okay, and so on and so on and so on. There's this pattern of 4 numbers that just gets repeated and repeated and repeated. So if I'm looking at example 7, number, I to the 33rd power, there's a couple of different ways that I could do this. Lots of different ways, really. One of them is just to keep counting. You've got, 12, so 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33 is going to be on that top row, so I33 is going to equal I. That's not a very efficient way of doing that problem. I33 is going to be the same thing as just I. I think a much better way is to take I33 and say, well, I can split up I33 into I32 times I to the first. Because I know about powers and exponents and algebra, I could split it up in that way. There are other ways I could split it up, but that's one way. I could certainly split it up. And I've memorized that every time I have a multiple of 4, that equals 1. And so I'd have 1 times I to the first. That's I. I think that's a much better way of doing that problem. Okay, let me give you another example before we go to the negative. If I said I to the, let's do 27th power. Okay. I think instead of counting, I counted to 27 and 27 was right there. It looks like it's going to be equal to I to the third based on just counting. I don't want to count though. Okay. I think what you should do is try to find a multiple of 4 that's nearby. So I could say that I to the 27 is like I to the 24th times I to the third. Find a multiple of 4 because we know that multiple of 4 is equal to 1. And so then we just have 1 times I to the third, and we know I to the third is equal to negative I. So if I do I to the negative 14th, okay, I to the negative 14th, I think the negative numbers are kind of tricky, but I guess you could count backwards and do kind of the same thing, but I don't want to count. I would find a multiple of 4 that's nearby and split it. So I might call I to the negative 14th, I to the negative 12th times I to the negative 2nd. Okay? Maybe. There are other ways to do this, certainly. But that's what I would do because I know that any multiple of 4 is going to equal 1. And so I'm looking at I to the negative 2nd power. All right? I to the negative 2nd, well, remember what negative exponents do. Negative exponents flip to the other side of a fraction. So that's like 1 over I to the positive 2nd. And you've memorized that I to the 2nd power is 1. So I'm looking at 1 over 1, which is 1. Oh, shoot. I messed up. What's my mistake?
I don't know, but I'm just completely lost on all of this.
Ha! All right. Okay. Time out. I'll go back to that. I to the 2nd power is not 1. What's my mistake? I to the 2nd power is negative 1. So that's a pretty large mistake there. Okay. Pretty large mistake. I to the 2nd power is negative 1. And so I've got 1 over negative 1, which is negative 1 there. Okay. Pretty big mistake. Couple of things to memorize here. I to the 2nd power is negative 1. I to the 4th power is positive 1. We're looking for multiples of 4.